Before anyone lays a single brick for a skyscraper, an architect has to create this incredibly detailed blueprint, right? Every single pipe, every wire, every structural beam is all planned out way in advance. Well, it turns out the exact same thing happens with the apps you use every single day. And we call that systems design. It's the secret blueprint that makes it all just work.
So that's really the big question we're tackling. How do you go from just an idea to this complex, functional plan for an entire app? How is that digital blueprint created before anyone even thinks about writing a single line of code? Okay, let's dive in and find out. So here's our game plan. We're going to go on a little architectural tour. We'll start with the architect's big vision, then we'll look at the master blueprint, then we'll design the individual rooms, take a peek at the hidden plumbing, and finally, see how the whole thing is built to last.
First up, the architect's vision. Because just like a building, every great system starts with a really clear understanding of the problem you're trying to solve. This is the crucial step where you go from asking what to figuring out how.
This whole process really begins with a split between two big phases. First, you've got analysis. That's all about figuring out what the system needs to do by talking to users and gathering all their requirements. That's the logical idea. And then comes the design phase. That's planning out how we're actually going to build it. That's the physical blueprint. Let's make this real for a second. Beaverbrooks the jewelers had a classic problem. Their information was all over the place, their staff were spread out, and they were just drowning in what they literally called a mass of email going round and round. They couldn't track orders, nothing was centralized. This was their architectural challenge.
And the payoff for their new systems design? Get this. They built a central system that cut their administration time in half. That's a 50% improvement. It's a perfect example of how a good blueprint doesn't just look nice on paper, it solves real business problems and gives you a massive return.
At the end of the day, any good design has a checklist it needs to tick off. It's got to be easy to use, fast and reliable, secure, and of course, flexible enough to handle changes down the road. You can think of these as the client's non-negotiables for their brand new digital building. Okay, let's zoom out a bit for our second stop, creating the master blueprint. This is where we're looking at the overall structure, what we call the high-level system architecture.
So what is systems architecture? Well, it's pretty simple, really. It's the master plan that shows how all the major pieces, the software, the hardware, the data, all fit together and talk to each other. It's the bird's eye view of our entire digital construction site.
A huge choice you have to make early on is how you structure this thing. With a simple two-tier model, your computer, the client, does a lot of the heavy lifting. But in a more modern three-tier model, the work is split up. Your device only handles the display, while separate servers handle the thinking and the data. It's a lot more scalable and way more secure.
All right, we've seen the big picture. Now it's time to zoom in. Section 3, designing room by room. Now that the master blueprint is set, we can start designing the individual pieces the user will actually see and interact with.
And the guiding philosophy here is a famous one. You've probably heard it. KISS, or keep it simple, stupid. Seriously, the best designs are often the simplest ones. And why is that? Because a simple modular design is so much easier to fix and upgrade later on. It means you can renovate a room without having to tear down the entire building.
So when we're designing these rooms, the user interface, there are a few things that are absolutely key. It has to be clear, consistent, and fast. This is basically the interior design of our app. You want to make sure it's a seamless, intuitive experience. Are the doors easy to find? Do the windows open smoothly? Is everything right where you'd expect it to be?
All right, now we're headed into the basement for the most critical part, the stuff you never actually see. Section 4, the unseen data plumbing. We are talking about the database, the hidden network of pipes that carries all the information through the system. So what happens when that plumbing is a total mess? I mean, what if the pipes are all crossed up, or data is just stored in all the wrong places? Well, you get leaks, you get errors, you get completely unreliable information. It's a nightmare. These leaks have a technical name, data anomalies. But really, they're just these maddening, frustrating inconsistencies that pop up whenever you try to add, change, or delete something in a badly designed database. Like, say you update a customer's address in one spot, but it stays the same somewhere else. That's a data anomaly. Just take a look at this table. It's a mess, right? This is what we call unnormalized data. See how Fred's toys and its address are just repeated for every single product in their order?
If they move, you'd have to go in and update their address in multiple places. It is a recipe for disaster.
So, how do you fix this disaster? Well, the solution is a process called normalisation. It's this systematic way of cleaning up your data, organizing it into neat, logical tables to get rid of all that repetition and prevent those errors. It's how you design the plumbing correctly right from the start.
Now, it might sound complicated, but the basic idea is you're just methodically cleaning house. You're breaking down that one big, messy table into smaller, more logical ones. You get rid of repeating groups, you make sure every bit of data is directly related to the main ID of that table, and you clear out any weird indirect relationships.
And the golden rule, the end goal you're aiming for, is this beautiful, simple phrase: every single piece of data depends on the whole key, and nothing but the key. When you achieve that, every piece of information has one and only one place to live. No more repetition, no more anomalies.
Okay, last stop on our tour. Let's talk about the long-term view. Section 5, building to last. A great architect doesn't just design a building for today, they design it for tomorrow and the day after that.
A huge piece of this is something called scalability. This is the system's ability to grow from handling, say, 10 users to 10 million users without slowing down or breaking. It's like building the foundation of your house strong enough that it can support a future second, third, or even 10th story. And of course, you can't build to last if the whole thing isn't secure. This is where we install the digital locks, the key cards, and the alarm systems. Authentication is basically asking, are you who you say you are? Authorization asks, okay, but are you allowed to do that? Privacy scrambles the data from prying eyes, and integrity makes sure nobody messed with it along the way.
So, I'll leave you with this. The next time you open up an app, doesn't matter if you're ordering food, checking your bank account, or just scrolling through photos, take a second. Think about its architecture. Now that you know what to look for, what invisible design choices, what hidden blueprints will you be able to see?